Lesson 22.2, Task 1. Compare two data sets. Statistical measures offer a way to compare sets of data to one another. You have studied the various statistical measures for single variable data sets. Seasonal snowfall data for Washington, D.C. and Denver, Colorado are shown in the tables. Alright, so you can see in the picture it says a blizzard on February 5th and 6th in 2010 dumped 17.8 inches of snow on Washington, D.C. So in the year 2010, you can see that the snowfall amount is much greater than the other years here. Alright, for Denver, Colorado, again, it gives you the number of years and the amount of snowfall in inches. And to look at this graphically, it's probably easier to make a like a graph to look at that. So what I want you to do is pause the video and make a graph, and then we will look at the data and see what we can determine from the data set. Okay, hopefully you took time to make a graph so that we can answer these questions. Alright, so I'm going to go ahead and pull up the graph I made and scanned in. It's a poorly drawn graph, but hopefully you can see how the distribution lays. Alright, so across the bottom I put in years, starting with number 1 represents the first year, and then up the left-hand side, which would be your y-axis, that's snowfall in inches. So Washington is the top graph and Denver is the bottom graph. So you can see if we're looking at the snowfall in inches, year 3, that's the year that they got the big snowstorm, it is very much different than the rest of the graph. Okay, so that one more than likely is going to be an outlier. Alright, so on the bottom graph is Denver. I did the same thing, put the years across the bottom, starting with the first year as number 1, and then snowfall in inches up the left-hand side or your y-axis. You can see this one has more snowfall, and it's more evenly distributed throughout the years, so it kind of goes up and down, but definitely more overall snowfall in Denver than Washington, except for that year 3 in Washington. So let's see what the questions ask. Alright, so it says compare the shapes of the distributions in terms of the context. Select all that apply. The shape of Washington's distribution is skewed to the right. Alright, so the fact that we have this high bar on the left would make it skewed to the right. Remember, it's always skewed kind of on the opposite side as what you expect. The shape of Washington distribution is skewed to the left. Well, it's not skewed to the left if it's skewed to the right. The shape of Washington's distribution indicates that Washington's seasonal snowfall is typically under 20 inches, but there are occasional winters where snowfall is greater. So if you look here, you can see this is 20 inches, and you can see pretty much all but 2, maybe 3 years is below 20 inches. So that one would also be true. Typically under 20, but occasionally it's greater, so that's true. The shape of Washington's distribution indicates that Washington's seasonal is typically over 20. That's not true. And the shape of Denver is skewed to the right. The shape of Denver's distribution is basically uniform. All right, so the graph for Denver is kind of up, down, but it is kind of uniform. It doesn't look skewed to the left or the right. So I'm going to say, I believe this one is a correct answer because it is pretty uniform. And the shape of Denver distribution indicates that it is typically over 80 inches. It's not typically over 80. The shape of Denver distribution indicates that seasonal snowfall ranges from 20 to 80 regularly. So that one would be true because if you look, here's 20, and it goes from around 20 to above 75. So the range would be from around 20 to 80. So that one should be true as well. All right, and again, this is easier if you form a graph and then you can look at the graph to kind of visually see if those answers make sense or not. All right, so it says identify any outliers for each data set. Well, Washington data, that one is easy to see that this one has an outlier here, and that one was the, I believe it's like 57 or something. 56.1. All right, so that would be the Washington data outlier. And if you go back to the table up here, you can see the 56.1, that was that third year, which was represented on the really high bar on the graph. All right, the Denver data set, I do not think it doesn't really look like it has any outliers. It kind of all falls between that 20 and 80 mark there. All right, so it says interpret your answers in terms of the context. So the sample answer here says, although Denver has no seasonal snowfall amounts as unusual as 100 inches, Washington's seasonal snowfall amount of 56.1 inches in 2009 and 2010 was much greater than the other winter seasons. So that's showing that the 56-inch one for the Washington graph was much higher than all the others. Compare the centers of data sets in terms of the context. Determine whether the mean or the median is more appropriate for these data sets. Explain your reasoning. All right, so what I would do is go to my calculator and I would go to stats and edit, and I would enter the table here, just the snowfall amounts. You don't have to enter the years, and then do like we practiced in the last example, go to 1var stat. So go to stat, calculate 1var stat, and when you do that, it's going to give you your mean, your mode, your Q3 and Q1, so you can find your interquartile range and your median, and all that comes from 1var stats right here if you know how to do that. All right, so I have already looked these up, and so I'm going to write these down here so we can look at the data. So for Washington, the mean was 15.4. The standard deviation was 15.1. The interquartile range was 16.1, and the median was 8.95. And if I look at Denver, well, there we go. All right, if we look at Denver, I have a mean of 47.2. I have a standard deviation of 17.93. I have a interquartile range of 27.3, and I have a median of 47.2. All right, so let's look at the question again. Compare the centers of data, so that's your mean and your median, and explain your reasoning. All right, so it says, because the distribution for Washington is right skewed and has an outlier at the right, the mean is much greater than the median. So you can see here, the mean is 15.4, the median is 8.95. So to compare the centrals of two distributions, use the median, which isn't affected as much by the outlier. Denver's median is 47.2, you can see here 47.2, and is nearly 5 times Washington's median. All right, so Denver has a median and a mean of 47.2. All right, so it says on average, Denver gets 5 times more snow during the winter than Washington gets. When the outlier is excluded from Washington's data, Denver's seasonal snowfall is on average 4 times greater than Washington. So they looked at with the entire set of data, and then they reevaluated it with the 1 year missing from Washington, which was the outlier. All right, so it says compare the spreads of the data sets in terms of the context. Determine whether the interquartile range or the standard deviation is more appropriate for these data sets. All right, explain your reasoning. All right, so the simple answer here, because the outlier in Washington inflates the standard deviation but has much less impact on the interquartile range, use the interquartile range to compare the spreads of the two distributions. Denver experiences much more variation in seasonal snowfall than Washington does. When the outlier is excluded from Washington's data set, the data still indicates that Denver experiences much more variation than Washington does. All right, so remember from the graph, you can see most of these are low. Almost all of these are below 20 inches here for Washington, with a couple exceptions. And then here, the variation goes from 20 all the way up to above 75. So that's what it's talking about, that it experiences much more variation, which is what that standard of deviation is. All right, that's all for task 1. If you have any questions, let me know.